question again? Point C? Okay. So the slope of the line through B and C, so you're going to go up 3, 6. So it's a positive 6. And right, so it's positive 3. So your slope would be the rise of 6 divided by the run of 3. So that's a 2. So you write just plain old 2. Slope of the line through A and C is flat. So right away, if it's flat, 0. So here's a different question I'm going to add in here. What is the slope of this line here? Undefined, right? Even though I didn't ask you, you should be able to do that. My second question is, do you know what we would describe these two lines as? An undefined slope and a 0 slope? How do they intersect?
Perpendicular.
Yeah, perpendicular. You know that word means right angle? They intersect at a right angle? Is that a yes or no?
Yes.
Okay. Just checking, because that's a vocabulary word that's old, but we should start thinking about perpendicular slopes. But if you had, just curious, one other question, 2 lines that were parallel. What did you say about those slopes?
Parallel.
Yeah, but what would you say about their slopes?
They have the same exact.
Do you guys agree?
Yeah.
Wouldn't they have the same exact slope? Because they're at the same angle, right? So you'd go over the same amount as you'd go up on each graph. It would be the same on both, right?
Yeah.
Like when I bring this line in here, so if I take that line, it's still gonna be the same steepness, right? Parallel lines have the same slope. Something else to start thinking about. Okay, for part 2A, the directions are determine whether each ordered pair is a solution. I'm going to just go through 2A, and then you guys can check 3A on your own. You're going to take the graph, and you're going to replace the x and y, the x and y from the coordinate. So 8 is the y value is equal to 2 times 4 plus 8. And we're checking to see if this is equal. So this is 8 plus 8. And that's not equal, right? So we'd say it's not a solution. So no, not a solution, no. That's the first answer. Part B is what quadrant does the point lie in? That's quadrant 1. Okay. So for part B, the quadrant is quadrant 2, right? Did this turn out to be a solution?
Yes. Yes.
Yes. So you should be able to work that out and get a yes. All right.
Is it going to be wrong if we write yes, or do we have to write it as a solution?
If the question is it a solution, you can just answer yes.
And do you have to write quadrant, or can you just do it?
You could write, since it's asking what quadrant, you can just write quadrant 2. But here's another question for you. What if it was right here? It's not on a quadrant. Where would you say it is? It's on the y-axis, right? What if it was right here?
Origin.
It's at the origin, right? So I could ask you those questions too. Okay? Okay, complete each solution. So it's telling me x is 12, so I have to find y. So, you guys see that better back there? So y equals negative 2 times my x value of 12. So negative 24 plus 4, negative 20. So negative 20 is the x value. I mean the y value. This side, a little bit different because 5 is the y value, right? So we're going to say 5 equals negative 2x plus 4, and it becomes the old 2-step problem. Subtract 4 from both sides, and you get 1 equals negative 2x. Divide by negative 2. So x is equal to negative 1/2. Does that make sense?
Yep.
Olivia?
Whenever you're trying to find the x, are you always going to do a two-step problem?
No. If it's a two-step problem, you are. If it's a one-step problem, you would do a one-step. It depends on. It just depends. It could be. It just depends on what's on the right-hand side. So there's never really an always. You have to think through all your old things and see what you can use. Okay, slope here. You don't need to draw a graph. It's dropping by 2. And it's rising by 3. So your slope is negative 2/3. Nope. Yeah. Rise over run. Okay. Nadif? Yeah. If it helps you guys do B in a table, you would put x is 6, y is 9, x is 6, y is 12. Right, because you have an increase of 3 and a change of 0. So it's 3 over 0, so that's undefined.
So we should just write undefined.
You would write undefined. That's your answer. What is the picture of that? You should be able to answer that yourself. So I know I'm trying to help you answer it, but in the long run, you want to be able to do that. So if I count it by 3s, 3, 6, 9, 3, 6, 9, let's answer that yourself. Over 6, up 9, right? Over 6, up 12. So what is undefined? Right, vertical. You can answer those questions by yourself if you get nervous on a test. Draw a picture. Okay? Okay, next page. Complete, so I'll do one, and then you guys can do the other. So a sample problem would be, yes, I want you to complete a t-table. I'm going to pick a harder one. How about this one? I'm going to pick multiples of what? 3. And I'm going to try to get them to stay on the graph. So negative 3, 0, and positive 3. If those don't work, I can add another one in. So 2. So if I do 2/3 of negative 3, 2/3, remember that was a warm-up, of negative 3? No, it's negative 1. This is right here, negative 1, right here. That reduces to a negative 1 over a positive 1, so we get a negative 2.
Wouldn't that be negative?
Yeah.
Oh, and then I have to add 2.
Yeah,
I forgot to do the rest of it.
Yay, I got this.
So it's negative 2 plus this 2. So you get a 0. When I plug the 0 in, I get 0 here. So 2. 2/3 of 3 is 2. Add 2 more and you get 4. Then look and see if it fits on your graph. If it doesn't, you have to do something different. So 0. Negative 3. 0. Label. And then 0, 2. And we do the third point to make sure we haven't made a careless mistake. Over 3, up 4. Then put your line in. And remember, your line goes on forever, so you should show that. That's part A. Part B is, I forgot the directions, graph, and part C, find the slope. Well, you can find it from the graph, but you should also be able to just see it from the equation, right? 2/3, so up 2, right 3. Got it? All right, you guys, take that home and study it.